might be pumping grain, we might be pumping corn feed, whatever. But we do all that with smaller pipes coming into big tanks, right?
So there's two 25% rules, one
No,
that says when to draw and one that says whether to taper it in or out
That's on the run-out.
on the run out.
Yes. Okay. And this is a separate deal. There aren't any fillets around here. Here we just have two cylinders coming together. Okay. So you can kind of see the different looks you get. This one on the left is less than 25%. It's a straight line. This one's greater than. We do the actual projection. And this is one just to know, the last one. If the two intersect and they are the same size, the line of projection will always be 45 degrees. Okay, that's this one. Okay. You don't even need to really project this. Just find quadrant, quadrant, and draw a straight line. And that will be the projection. You're keep in mind, this is that 45, 45, 90 triangle, right? You're going to get the same thing, and it happens a lot in the architectural world, where roofs come together. Because generally we do not change the slope of roofs. Now, today our roofs are getting pretty crazy due to CNC truss companies and their saws, but for the most part we try and keep them the same. You do the same thing when you have a prism intersecting a circle. Use the 25% rule. Again, here you see the prism coming down in. It's here, it's wrapping around the side. Use your 25% rule. If this is less than the 25% of this guy, we do not project that offset. Now it's wrapping down around. It should drop down the true projection here. If it's larger, like this one shows, here we do project that wraparound portion, because now people will see it. And then if they come in the same size, the last one, you now have a tangent condition, where you have a linear and curved surface coming together at tangents. We do not project that. Right? We just bring these lines straight down to the point of tangency, stop them. So when you have curved surfaces coming into curved surfaces, you have that convention of 25%. Same thing when you have linear surfaces coming into cylinders. Page 534. This is going to be the exact same scenario, just reversed with negative shapes. And when we have negative shapes, again, here, you've got a hole drilled in. That's just this very small distance. It's less than 25%. We're really not going to see that here or here. So we just go straight. Here it's gotten a little bit bigger. This negative cylinder coming through. We're going to project that wraparound, because that material's been removed. Then the same thing for the prism down below. So those are worth looking at. Any questions so far? Okay, the conventions we're talking about here, folks, they're there to make your life easier. Okay? So these are things that benefit your drawing style. They're worthwhile knowing them. And so you were looking for when fillets come into cylinders, cylinders come into cylinders, prisms come into cylinders. So those are the cases. As soon as you see that happen, I'd be flipping into this chapter and looking through these 3 pages and say, you know what, this is the case I have. Hopefully you got a note in there and some color saying use 25% rule. And then you can run a couple numbers and know how you want to project it. Yesterday we looked at some 3-view drawings of individual geometric shapes. Here's another good page for you to look at. This one kind of does the same thing, but it shows shapes in different orientations and shows you the different projections that occur. Again, as I'm doing something and I've got a cylinder, you know, I might come in here and find a cylinder and say, you know, how does that thing project it? And then I can know about what I'm going to find on my drawing. So a good place to start if you don't really know how your projection's going to work. All right, I think that's enough terms for today. There's a lot in those pages. Now, just so you know, we're going to take a quick break, and I'm going to draw a couple figures like I mentioned, and I'm going to basically use the procedures as shown on page 532 to solve the geometry problems that occur here. So let's take a quick break. As soon as everybody's back in the room, we'll go ahead and produce those two drawings.